Welcome. Today I'd like to talk about how to safely set up distillation. We'll be looking at a simple distillation, fractional distillation, and steam distillation. First, let's look at the parts of a simple distillation apparatus. The distillation flask, sometimes called the still pot, is where you place your mixture that needs to be distilled. Directly attached to the distillation flask is a three-way adapter, sometimes called the distillation head. In the three-way adapter, we have the option to insert a thermometer to monitor the temperature of the distillation. The piece of glassware that holds that thermometer in place is called the thermometer adapter. Attached to the side of the three-way adapter is the condenser. At the end of the condenser is a vacuum adapter. Attached to the bottom of the vacuum adapter is your receiving flask. For fractional distillations, the only key difference is the presence of a fractionating column, which increases how effective the distillation apparatus is at separation. Now that you're familiar with the parts of the distillation apparatus, let's look at how to properly assemble it. Keep in mind what components you're going to be using, like your source of heat, your source of water for the condenser, and what size glassware you're going to be using. I recommend setting up your distillation apparatus directly next to the sink that supplies water to your condenser. This minimizes the distance you need to stretch your hoses to and from the sink. Before setting up any equipment, prepare a clean and organized lab bench. Any clutter or messes from earlier parts of your experiment will make it more difficult and dangerous to set up your distillation. When connecting ground glass joints, it is advisable to use a small amount of a stopcock grease to keep the ground glass joints from seizing or leaking vapors. Once you've placed a small amount of stopcock grease on the inner joint, insert it into the outer joint and twist it around to ensure a complete seal occurs between the inner and outer joint. You don't need to completely coat the entire length of the ground glass joint to ensure an effective seal. In fact, if you use too much stopcock grease, you could make a mess or contaminate your sample. Always keep in mind that stopcock grease is not intended to hold a piece of glassware in place. Sometimes students mistakenly believe that stopcock grease acts like glue. This can lead to very expensive glassware falling to the bench top. Next, set up your ring stands and clamps. The very first piece of glassware you want to set up is your distillation flask. Your distillation flask needs to be firmly supported by either a clamp or your heating mantle. Never mount your distillation flask without direct support. Don't rely on the strength of a Keck clamp to support the weight of a distillation flask. You want to place your distillation flask at an appropriate height so that you can easily place your heat source below it. If you're going to be using a heating mantle, you just need to allow a little space below the distillation flask. In fact, you can have your heating mantle support your distillation flask directly. If you're going to use a Bunsen burner, you'll need to leave several inches of clearance from the top of the Bunsen burner barrel. It's much easier to get this spacing right before you've set up the rest of your distillation. Also, when using a Bunsen burner, don't use a rubber-coated clamp or plastic Keck clamp on the distillation flask. These can catch fire when heated with a Bunsen burner. Once you've set your distillation flask to an appropriate height, attach your fractionating column to your distillation flask. If you are setting up a simple distillation, you can skip this step. Then attach your three-way adapter to the fractionating column, or your distillation flask if you're doing a simple distillation. You want to make sure that your distillation column is perfectly vertical. Any tilt in the column will decrease the efficiency of the distillation. If necessary, add another clamp to hold the three-way adapter firmly in place. The three-way adapter has an outer joint on top where you must attach either a thermometer adapter or a ground glass stopper. If you need to use a thermometer, make sure that the rubber septum in the adapter holds the thermometer firmly. If your rubber septum is worn out, you should ask your instructor for a new one. When adjusting the height of the thermometer, you want to place the middle of the thermometer bulb even with the bottom of the exit chamber of the three-way adapter. If you need to adjust your thermometer after you set up your three-way adapter, be careful not to break the glass thermometer. I recommend clamping your vacuum adapter firmly with a clamp before inserting your condenser into the apparatus. Attempt to get it to the correct height so that you have a minimum number of adjustments to make when inserting your condenser. Before inserting your condenser, make sure that everything is firmly supported by clamps. Now, insert your condenser. Before doing anything else, check the entire apparatus to make sure that no glassware is loose. Once all your glassware is in place, you want to add your condenser hoses. Make sure that they are firmly attached and that the return hose is placed in the sink. We typically place our return hoses into plastic pipes like these to keep them from moving around. You need to test your hoses before you attempt to start your distillation. Many of our sinks have reversed orientation for the valves, so instead of lefty-loosey, righty-tighty, the faucets work the other way around. It's probably a good idea to check which type of faucet you have before setting up your hoses. Also, the valves on our faucets allow a high volume of liquid to flow through. If you open up the faucet handles too much, the high pressure will cause the hoses to pop off and spew water everywhere. Now, you want to set up your source of heat. If you are using a heating mantle, make sure that it matches the size of your distillation flask. Next, you want to check your heating mantle cables for signs of wear. If there's a frayed wire or an exposed wire, show your instructor immediately and select a different heating mantle. You always want to use a heating mantle controller. Never plug the heating mantle directly into the outlet. This will cause the heating mantle to overheat and damage your equipment. It could even potentially cause a fire. If you are using a Bunsen burner, make sure that you know how to use the Bunsen burner properly. We have a great video on that. I'll put a link up in the corner and in the description. When heating a round bottom flask with a flame, always use a mild flame. That means your flame should be blue, but not with the bright blue inner cone. A hot flame like this one could potentially crack the flask. When using a Bunsen burner, you always want to place a steel mesh with a ceramic center in between the flame and the round bottom flask to dissipate some of the heat. Also, make sure that all flammable solvents are away from your Bunsen burner. Let's go over a few safety considerations. First, always check your glassware for cracks before using it. Next, always wear lab goggles before heating up any glassware. Usually, you want to fill your flask to somewhere between 1/3 full and 1/2 full. It's okay if you fill it a bit more than that, but I recommend never filling it beyond 60% full. Many procedures will call for the use of boiling stones to promote smooth boiling. You always want to add those stones before you start your distillation. Before turning on the heat, get your instructor to check out your distillation apparatus, particularly if this is the first time you've ever set one up. An important safety rule that you must follow is to never leave your distillation unattended. Either you or your lab partner should always be present. Once you've started heating, avoid touching the glassware, the metal clamps, the distillation column, and the three-way adapter. If there's ever an emergency during your distillation, turn off your source of heat immediately. Once you've started your distillation, you need to be patient. It takes time to bring the contents of the distillation flask up to the boiling point. You might be tempted to crank the heat all the way up to get the distillation to go faster, but slow and steady will get you a better result. At first, the contents of the flask will start to bubble, and condensation will form on the inside of the distillation flask. Once the contents of the distillation flask start to boil, the vapors will work their way up the fractionating column. If you look carefully, you might see the reflux ring. This is the zone where the vapors from the distillation will condense and drip back down the column. As you continue to heat, this reflux ring will continue to rise up into the three-way adapter. If you are monitoring the distillation with a thermometer, you should see a sharp spike in the temperature reading on the thermometer at this point. Eventually, you will start to see condensation inside the exit chamber of the three-way adapter. Once the hot vapors hit the condenser, large drops will form. These drops will collect together and fall into the receiving flask. Ideally, you want to get a nice, steady flow of drops entering the receiving flask. For most fractional distillations, you should see about 1 milliliter of material collect per minute. That's about 20 drops per minute. But don't be too worried if it's a little faster or slower than this. If you are doing a simple distillation, you might get a slightly faster rate of distillation. When your distillation flask starts to run out of material, you might observe that the temperature on the thermometer drops. This is perfectly normal. It just means that no more hot vapors are making it up to the three-way adapter. You either need to turn up the heat or stop the distillation. In a couple of our labs, we ask our students to do a steam distillation. This is a clever technique where we distill water along with volatile organic compounds at the same time. The steam from the boiling water carries the vapor of the volatile organic compounds to the condenser. Since the organic compounds often aren't soluble in the water, the drops of liquid that form in the condenser are typically cloudy. In this example with cinnamon oil, the primary compound recovered is cinnamaldehyde, which has a boiling point of 248 degrees Celsius. Regular distillation of cinnamaldehyde from cinnamon bark at this temperature is impractical. So a steam distillation is ideal. You can see that the receiving flask for this distillation is a heterogeneous mixture of oil and water. We will later use a separatory funnel to extract the cinnamaldehyde from the water, but we'll save that for another video. I hope you enjoyed learning about how to safely set up a distillation. If you have any questions or suggestions, please leave them in the comments below. Also, subscribe to the channel so that you don't miss our upcoming videos. Thank you for watching.